So let's begin with question 1, where we have a bond with an annual coupon payment of $50. So the coupon is $50. It has a par value of $1,000. And obviously the coupon is then 5%. You're told it has a maturity of 5 years. And you're told that the yield curve is flat at 10%. So before we embark on any calculations, just remember from the lecture this relationship here. Then we draw price against yield, and we plot it like that. We know that when yield is equal to the coupon, so when yield to maturity equals the coupon, the bond is priced at par. Here, of course, our coupon is 5, our yield is 10, so we know that the bond is going to be priced at a discount. So before we undertake any calculations, we know that the bond is going to be priced at a discount. So let's just undertake those calculations. So we're just going to set it out as usual. Yeah, 1, 2, 3, 4, 5. Now we want the cash flows. So the cash flows are, of course, $50, $50, $50, $50, and of course 1,050. And then we want to find the present values of those cash flows. The present value at 10%. So I just grab my calculator. It's going to be 50 divided by 1.1. So 50 divided by 1.1, 45.45. 50 divided by 1.1 squared, we get 41.33. 50 divided by 1.1 to the power of 3, we get 37.57. 50 divided by 1.1 to the power of 4, we get 34.15. And finally, 1,050 divided by 1.1 to the power of 5, we get 651.97. I add each of these together, 45.45 plus 41.33, add 37.57, add 34.15, add 651.97, we get the price of 810.47. So that's the price of our bond, 810.47. And as anticipated, we see that the price of this bond is at a discount to the par value of 1,000. We're now asked to calculate the duration. So if you remember, the equation for duration is equal to the sum from t equals 1 to big T of t times by the cash flow in each period t, discounted at the yield to maturity, divided by the price. We already have the price. We already have this component here. So all we've got to do now is take each present value and multiply it by the time period that it's received. So you now need to find t times by the present value. So obviously this is just 45.45. I now need 41.33 times by 2. I can do that, 82.66. I then need 37.57 times by 3. So I get 112.71. I then get 34.15 times by 4. I get 136.6. And then finally 651.97 times by 5. So that's 3,259.85. And let's add all of those together. So 45.45, add 82.66, add 112.71, add 136.6, add the final one, 3259.85, we get 3,637.27. If I want to find the duration now, I need to take this number here, the duration equal, and then divide it by the price of 810.47, and I get an answer of 4.49. So 4.49. And then the units that we use to measure duration are years. So as we can see, because this is a coupon paying bond, the duration is less than the maturity of 5 years. Okay, so now we want to utilize the duration. So let me just clear this information away. Just make a note of the price. The price is of course 810.47. Just grab another colour pen. So we're going to remind ourselves of this relationship here. So we've got the price here, and it's a convex relationship. And effectively what we have just found is the tangent at that point. So we effectively found the tangent at that point, where the yield to maturity is 10%. As so. So at 10%, we have found the price to be 810.47. And if I just overemphasize, now we're going to consider a new interest rate of 9%. So what would happen if the interest rate goes to 9%? Well, if it goes to 9%, I'm going to overemphasize it, of course. Then you can see that the price is going to rise. It's going to rise to that amount there on the price yield curve. However, we are going to utilize duration. And duration assumes this linear relationship. So our estimate is going to be around about there. So as you can see, our estimate, our price estimate, is going to be slightly beneath the actual price, which I'll just call P star. So let's just find our estimated price. So we utilize this relationship. The change in price is equal to minus D times by delta 1 plus I divided by 1 plus I. So we've got all of these ingredients. So 4.49, so it's going to be minus 4.49 times by the change in interest rates, where we're going from 10 to 9, so the change in interest rates is minus 1%. Ignore the 1 plus, because if you imagine it, 1.1 take away 1.09 or vice versa is the same answer. So that's going to be a fall of minus 0.01. And we divide that by the original interest rate, which is 10%, so we divide by 1.1. Let's grab our calculator again. So minus 4.49 times by 0.01. The minus is obviously going to disappear. Minus times minuses gives us a plus. And then we divide that by 1.1. And we get an answer in percent of 4.08%. Now the original price is 810.47. I just want to add 4.08% to that. So that's very easy. If I just multiply this by 0.0408 and then add 810.47 onto it. So 810.47 times by 0.0408 and then add on. So the change, the delta bit, the change in price is 33.07. So the new price, which I'll call P star, our estimated price, P est, is 33.07 plus the 810.47. So 810.47 plus 33.07, which is 843.54. So that's our estimated price. Now we know that the actual price is going to be slightly higher than that. So the actual price is going to be slightly higher. If we want to make a correction for this, we need to add something back in. And the thing that we add in is to reflect the convexity. So with reference to your lecture slides, you'll see the reason for using convexity is to increase the accuracy of that calculation.